Hi, welcome to the first video of Unit 9B, Day 3. We're going to look at special segments and how they work with circles. The first one we're going to look at is when you have segments that intersect inside a circle. In other words, if two chords are intersecting in a circle, we are going to say that the products of the lengths of the chord segments are equal. So when we say chord segments, anytime you see an intersection of two chords, you'll see that each chord is divided into two segments, and not necessarily equally, right? The C might be much longer than D. And then here, A and B, they don't necessarily have to be the same as each other, okay? So it says the products. Products means multiply. When you see product, that means multiply. So you multiply the chord segments together, and you'll get two equal values. So I look at this chord and I go, okay, this chord is divided into a length of A and a length of B. I'm going to multiply those together. This chord is divided into a length of C and a length of D. I'm going to multiply those together. And that is going to be an equal equation. Let's look at an example. When I look at this first one here, it says to find X. So I can see that I've been divided into a 3 and an 8. And then over here, I've been divided into a 6 and an X. So these two, the 6 and the X, if I multiply them together, that's going to be equal to the 3 and the 8 multiplied together. So 6 times X equals 3 times 8. So 6x equals 24. Divide both sides by 24, or sorry, by 6. And I see that x equals 4. Okay? When I look at the next example is kind of an interesting one because it's going to be real easy to make a mistake on this one. When I look at this one, my one chord is really simple. It's divided into X and X. Easy peasy. But my second chord is divided into 2. And you kind of almost want to say 10, but that 10 is only going to be to the center point. The 10 is the radius. So if the 10 is the radius here, that means the radius on this other side all the way out to the edge is also 10. But I've used 2 already. So left in here is really 8, and this whole piece here is 18. So make sure you're really looking and really paying attention to that. I'm going to zoom in even closer so you can see that really well. Okay, so that was just 10, which means all my radii are 10. I used 2 there, so there's 8 left, so that this radius is 10, which means this whole segment up till where I hit the other chord is really 18. Okay, x times x is not 2x. X times x is x squared. 2 times 18 is 36. And then we get rid of that square by square rooting. And in Algebra 2, we'd say the answer was 6 and negative 6. But in geometry, these x's here, they can't be negative 6 because they're lengths. So my answer is just 6. Okay, so that is the first property for today. We're only learning 2 properties today. The first one, if I have 2 chords intersecting in a circle, all you have to do is multiply their pieces together and they'll be equal. The next one is a really weird formula, and when you look at it first, you're going to go, that doesn't make any sense, I don't get it, what are you talking about? Doesn't make any sense. When you have segments intersecting outside a circle, okay, the formula is, it's going to be the external segment times the whole segment and that's going to equal the external segment times the whole segment. Which fundamentally makes sense. They're the same, so they equal each other. But that's not going to help you solve if you're using the same segment. So it's from the external segment and whole segment from one secant or tangent is equal to the external segment and whole segment of the other external, or the other secant or tangent. So let me show you what I mean. Okay? When we look at this picture here, this is two secants, and one secant I'm going to highlight in pink, which is going to go with the pink side of my equation, and the other segment I'm going to mark in the dark purple, which is this other piece over here. Okay, so when I look, I can see the external segment of the pink segment times the whole pink segment, the external segment of the purple segment times the whole purple segment. So what that looks like as a formula, if I were going to use this to write a formula, my external segment is this piece here from A to B. So A times B times the whole segment. My whole segment is all of this from A all the way to C. That's going to equal, oops, I'm going to switch colors. That's going to equal, now I'm going to look at the purple segment. My external segment from A to D times the whole segment A to E. Okay? And that's with two secants. If I have a secant and a tangent, I do the exact same thing. So I'm going to look at my two segments. One of them is pink, and one of them is purple. Okay, so I'm going to do my external times my whole. My external is AB. My whole on this one, if it's a tangent, my whole is also going to be the exact same thing. So that's going to be unique when you have a tangent, is it'll multiply to itself, right? And that's going to equal, then we do the other side. That's going to equal my external AC times my whole AD. And when you're solving this one, you can say this is really AB times itself, so this is really like AB squared, which we know is going to be equal to AC times AD. Okay? All right, so in the next video, we're going to start applying these two properties here. So we're going to apply two secants over here, and we're going to look at a secant and a tangent over here. And we'll do that in the next video. So come on back to see how we apply this formula to different pictures. I'll see you in the next video.